Every time you open a website, your browser and the server are having a conversation. You ask for something and the server responds, not just with the page, but with a 3-digit number that tells you exactly what happened. That number is an HTTP response status code. You've definitely seen a 404 or a 500, but there are over 60 of these codes, and they're split into 5 families. So today, we're going to understand them because once you understand them, everything in web development just clicks. Today, I'm going to walk you through them, and we're going to go over the ones that really matter, the confusing ones, the ones people trip on, and a practical insight about how these status codes work in layers when you're using browser automation. Let's get into it. Before we dive into specific codes, here's the mental model that makes all of this intuitive. HTTP status codes are 3 digits. The first digit tells you the category. That's it. If you remember nothing else from this video, remember the 5 families. Anything in the 100s means, hold on, I'm working on it, so mostly informational. If it's in the 200 range, it means, here you go, all good, signaling it was a success. If you see 300 and something, it means what you want exists, but it moved. Go look somewhere else. So content is now found elsewhere. If you're seeing something in the 400 range, it means something is wrong with your request. Basically, you messed up. So an error on the client's end. And lastly, if you see anything in the 500 range, it means something is wrong on the server end. It's me, not you type of deal. So basically a server error. There's a great restaurant analogy for this. Imagine you walk in and order a steak. So a 200 means, here you go, here's your steak. A 301 means, we move that dish to a different menu, let me grab it. A 404 means, we've never had steak. And a 500 means, the kitchen is literally on fire, I can't fetch your steak. Once you have this framework, every individual code is just a specific flavor within its family. Let's start with the good news. 2XX codes mean the request worked. 200 OK is the one you'll see the most. It literally just means, I got your request, I processed it, here's what you asked for. Every successful page load, every successful API call, you'll get 200. 201 created is what you get after a post request that creates something new. You submitted a form, you created a user account, added a record to a database, the server says, done, and here's what I created. 204 no content means, I did what you asked for, but there's nothing to send back. This is common for delete operations. You asked me to delete something, I deleted it, there's no body to return, we're done. And then there's 206 partial content, which is more interesting than it sounds actually. This is what makes video streaming work. When you watch a video online like this one, your browser doesn't download the entire file up front. It requests chunks using range headers, and the server responds with 206 for each chunk. That's why you can skip ahead in a YouTube video without waiting for the whole thing to load. 3XX codes mean the thing you asked for has moved and the server is telling you where to go instead. This is where one of the most common confusions live, 301 versus 302. 301 moved permanently means this URL has moved to a new address. Browsers and search engines should update their records. This is the redirect you use when you change your page's URL structure, rebrand a domain, or move from HTTP to HTTPS. Google will transfer the old page's ranking power and SEO to the new URL. 302 found means the move is temporary. The original URL is still valid. You're just being sent somewhere else for now. Browsers will keep using the original URL for future requests. Here is why that matters. If you accidentally use a 302 when you mean a 301, search engines won't transfer your link equity to the new page, so you could lose rankings and SEO for no reason. 304 not modified is a caching code. Your browser asks the server, hey, has this resource changed since last time I fetched it? And the server says, nope, you can use your cache copy. This saves bandwidth and makes repeated visits faster. 4XX means the problem is on your side. The server understood your request, but it can't or won't fulfill it because something about the request is wrong. Let's explain the main ones with a door analogy. Imagine you're trying to get into a building. 400 bad requests is the generic, I can't understand what you sent me. Malformed JSON, missing required fields, or invalid syntax. If you're building an API and you get a 400, check your request payload first. In our door analogy, this is the guy who walks right past the door. He didn't even know he was supposed to knock. The request itself doesn't make sense. You didn't follow the basic protocol. 401 unauthorized means you're not authenticated. You haven't proven who you are. Maybe you forgot to send an API key or your token expired. The name is actually misleading. It should really be called unauthenticated. This is the person who walks up to the door but has no badge. The door says, "Who are you?" 403 forbidden means you are authenticated. The server knows who you are, but you don't have permission to access this resource. You're logged in, but you're not an admin. Same door, but now the person has a badge, swipes it, and the door says, "I know who you are, and you're not allowed in here." This is a very common mix-up. 401 means, "Who are you?" and 403 means, "I know who you are," and the answer is no. 404 not found. This is probably the most famous status code in existence. The server can't find the resource at the URL you requested. Either the page was deleted, the URL has a typo, or it never existed in the first place. In our analogy, this is the person wandering around the hall. They can't even find the door. There's no door at this address. 405 method not allowed means this URL exists, but the HTTP method you used isn't supported. You tried to delete something on an endpoint that only accepts GET, for example. Back at our door example, the person found it, but they're knocking when there's a doorbell. The door is right there, but you're using the wrong way to interact with it, so there's no answer. 429 too many requests is the rate limiting code. You're sending requests too fast, and the server is telling you, slow down. APIs use this constantly. If you're scraping or automating requests and you start getting 429s, you need to add delays or respect the retry after header. In our door analogy, this is the person who got their badge rejected, so they tried again, and again, and again. Now the door locks them out entirely. Too many attempts, try again in 5 minutes. 5xx means the server broke. Your request was fine, but the server couldn't handle it. 500 internal server error is the catch-all. Something unexpected went wrong on the server. An unhandled exception, a crash, a bug in the application code. 502 bad gateway means your request reached a gateway or proxy server like Nginx or a load balancer. But when that proxy tried to pass the request to the actual backend server, it got an invalid response. So the proxy is fine, the thing behind the proxy is broken. 503 service unavailable means the server is temporarily unable to handle requests. Maybe it's under maintenance or it's overloaded with traffic. This is actually the polite error. It's the server saying, "I know I'm down, come back later." Search engines treat 503 differently than 500. They know to retry later instead of dropping the page from the index. 504 gateway timeout is like 502's cousin. The proxy server reached out to the backend, but the backend took too long to respond, so the proxy just gave up waiting. Status codes aren't just trivial, they have real consequences. For SEO, if Google's crawler hits repeated 4xx and 5xx errors on your site, it wastes your crawl budget, and Google may start crawling your site less frequently. Persistent 500 errors can get pages temporarily de-indexed, and using wrong redirect like 302 instead of 301 means you don't transfer link equity when you move a page. For AI crawlers, the rules are the same. If AI training crawlers or LLMs hit 404s and 500s on your page, the content gets skipped entirely. Persistent errors mean your content will show up less likely in AI-generated responses. If you want to see status codes in action, open your browser's DevTools, that's F12, or right-click Inspect, and then go to the Network tab. Reload the page. Now you'll see every request and its status code. So if you're building something and want to programmatically monitor status codes at scale, that's where automation comes in. You can programmatically hit these endpoints and notify whenever you don't see a 200 status code. That leads us to our next point. Now, there's something that trips up a lot of people when they start working with a tool like Browserless. Say you're checking for broken links, validating redirects, or monitoring page availability. There are actually two layers of HTTP status codes happening at the same time. The first layer is the API call itself. You're making a request to the Browserless REST API. That request has its own status code. If your API token is valid, your payload is well formed, and the browserless service processes your request successfully, you'll get a 200 back. That 200 means browserless received your request and ran it. But here's the thing, a 200 from the API does not mean the page you fetched returned a 200. That's a second layer. Let's say you ask browserless to navigate to a broken link on an existing site. The domain is real, the site loads, but the specific page is gone. Browserless returns a 200 on the API layer, the automation ran successfully, but the page itself returned a 404, and that lives in a response header called xResponse_code. This is browserless specific. Now, what if the domain itself doesn't exist? Some typo in the URL that leads nowhere? The browser can't even connect. There's no page to render, so there's no xResponse_code. Instead, browserless returns a 500 on the API layer itself because the automation couldn't complete. So the status code you care about might live in one layer or the other. The API response tells you, did the automation work? The xResponse_code tells you, what did the actual page say? But only when the browser reached the site in the first place. If you're building a broken link checker, a 200 with a 404 in xResponse_code means the link is dead, but the domain is live. A 500 on the API means the domain is unreachable entirely. Redirect validation, uptime monitoring, SEO auditing, they all depend on reading the right response code from the right layer. Alright, that's all I have on status codes. So I hope this video was useful for you, and if you did like it, please consider giving us a like and subscribe. It helps us with the algorithm and lets us know that these videos are helpful for the community. If you want to know more about browser automation, go ahead and check out browserless.io, and we'll leave some links in the description. Thank you for watching. This was Alejandro from Browserless. I'll see you on the next one.